So previously we discussed the human cognition of spatial information. Now we intend to look into more specifically spatial cognition with sensing and perceiving the real world. The spatial cognition concerns the study of knowledge and beliefs about spatial properties of objects and events in the world. Cognition is about knowledge, its acquisition, storage and retrieval, or even manipulation, and use by humans and also by non-humans like animals, and in modern day the intelligent machines. The cognitive system includes sensation and perception, thinking, the memory learning, language, reasoning, and problem solving, to name a few. The spatial properties include location, size, distance, direction, separation and connection, the shape, the pattern and movement, etc. These properties characterize the very small and the very large, which the geographers focus, and the scale is very relevant for all the human activities on the earth's surface. This scale is very important dimension which is required for spatial cognition. Such as if you take the example of migration, settlement and economic activities, etc. So here I would say that the scale would be very important to analyze as to how these phenomena are evolving. As such, it includes the space of settlements, neighborhoods, landscapes and regions. The spatial cognition sheds light on questions such as how spatial knowledge and beliefs are acquired and develop over the time. The nature of spatial knowledge, structures and processes, how people navigate and stay oriented within the space, how people use language to communicate with each other and about the spaces and the phenomena which are related to those spaces, and how aspects of spatial knowledge and reasoning are similar or different among individuals or the groups. The future of spatial information will concentrate on ways to which technologies are changing and how they draw cognition of space and place. So spatial information is the digital connection between location, the geographic space, the people, population, and their activities. So here again I would say it is the synthesis between man, nature and environment. This information can graphically illustrate what is happening where, how and why, to show the insight and impact of past, the present and the likely future. All of them would come into consideration. The human cognition of the spatial world, it relates with human scales. The world consists of objects, events, processes and a background environment. The study of cognition is about knowledge, its acquisition, storage and retrieval, manipulation, which are used by humans and other creatures, as I have mentioned, like even animals, they use this spatial cognition. Many of the animals, they navigate themselves using their knowledge about the space. I can give you the example of Siberian cranes, which travel hundreds of kilometers and navigate through the hostile human activities on the ground, and they reach to the destination and they keep on coming year after year. And in modern day, I would say machines, they also have spatial cognition in their, which is their inherent feature. Cognition includes sensation and perception also, thinking, reasoning and problem solving, memory learning. cognitive structures and processes are part of the mind that exist in a social and physical world. So, spatial cognition deals with the cognition of spatial properties of the world, including location, size, distance, direction, shape, pattern, movement, and inter-object relations. All of them, they are part of spatial cognition. Now, sensing and perceiving the world. You see, sensation is the first response, which includes visualizing, hearing, smelling, tasting, temperature, sensation, etc. So, and the perception is the active acquisition of knowledge about the self and the world through the senses. The characteristics of the perceived world is locational perspective, where world perceived from a point of view, and its meaningfulness to perceive meaningful, familiar objects and events. It is not like a cartographic map in the imagination. It is not a unitary representation with a constant scale, neither completely integrated. It consists of discrete pieces, for example, landmarks, routes, places, monuments, etc. The pieces determined by physical, perceptual, or conceptual boundaries. They are hierarchically organized pieces with multiple levels of pieces differing in status, for example, size. The cognitive maps have distortions also, which tells us about properties of cognitive maps and which are corresponding to the physical measurements. For example, Chennai is thought to be in the south of India, whereas it is actually southeast of India. Or more commonly, explaining the travel paths. For example, turns are referred more like right angles and curved lines are mostly straightened. Now, we would try to highlight the spatial learning and development. The learning is a relatively permanent change in cognition or behavior that results from practice and experience. Spatial knowledge is learned via one or more media of acquisition. Direct experiences, maps, models, photos, drawings, movies, verbal and written languages. The cognitive development is a systematic change in the content and process of cognition over time, including learning, maturation, and growth. From child to adulthood. Now, how we can use and learn spatial information? The main purpose of cartographic maps is to communicate spatial information and support geographical problem solving. Humans have the ability to quickly extract great amounts of information from spatial depiction, like images, pictures, or graphs, etc. Even non-spatial or non-perceivable information can also be displayed this way. We may call it as visualization or spatialization. Spatial information use convenient scales and viewing perspectives. We can perceive all from a single viewpoint. Spatial information highlight and clarify relevant properties also. They may also omit or downplay irrelevant properties. But here, the projections, the generalizations, even the exaggerations, omissions may mislead or distort knowledge in the spatial information. Similarly, perspective translation from overhead to terrain. From top if you are viewing any geographic space, or at normal height when we are observing the same phenomena at with our height over the Earth's surface. So this similar perspective translation from overhead to terrain level view may be confusing. And that is why the interpretation of aerial photograph or satellite imagery, I mean to say analog satellite imagery, needs proper training. So level view may be confusing, or interpretation of symbols, for example color, point, symbols or contour lines, may be difficult or misleading if you are not trained with it. However, training and experience with spatial information changes the way they are perceived and interpreted. Now we would like to highlight the maps and the spatial information. Here it is important to understand that the maps, also as they are representation normally to scale on a flat medium of a selection of phenomena or abstract features on it, or in relation to the surface of the earth. The production of map requires selection of few features in the real world to include within the space which is being represented in the map. It also includes classification, but this classification would be only of selected features, and that may also be into groups. For example, if we can pick out some of the features of the ground reality, for example houses, the rail network, roadways or houses, or even on the rail and road network, bridges, etc. These would be called as classification into certain specific groups. Another can be simplification. Now, the good example is, for example, the jagged lines like coastline. They need to be simplified depending on the scale and the interest of the users to represent this information, this spatial information. And on the contrary, there can be exaggeration also, exaggeration of features that to be included which are appearing too small to show at the scale of the map. But if we want to show them the minor information, then we have to exaggerate them. Lastly, the symbolization to represent the different classes of features chosen. Then the changeover to spatial information. The impetus for change began in two communities. First, the analysis, wishing to make pictorial representation quickly to see the results of spatial depiction of any phenomena, or to display data from large archives already in digital format. For example, census tables. Another can be the users seeking to reduce the cost and time of spatial information production and editing. So spatial information refers to visual display of information, particularly if it is abstract, generalized or schematic. Spatial information shows only a static situation and easy to use to answer certain types of questions, like how do I get there from here, or what is at any location. But it is a difficult or complicated answer to other types of questions, like what is the area of any lake, or what does image shows at any location in any pictorial representation. Now in both these queries, it requires to refer to the legend or to scale, which in many cases are user defined. So learning the interpretation is equally important than to represent them. There can be other representation of the world also. I mean in context of spatial representation. Maps are not the only representation of the world in modern times. Others includes the photographs, especially in modern day, the remotely sensed photographs, air photos, satellite imageries, the verbal description, and also all kinds of statistical data. If we can relate it with location all of them, they are other kind of representation of spatial information. But the uniqueness of the map among representation of the world lies in its content. Not only in the form of only content, as well as area shown in selective. Unlike air photos, satellite imagery, snapshots, etc., in the map, the area which is being represented and shown, they are well defined to the user's requirement. The maker has control over emphasis, unlike in aerial photograph or satellite imagery or snapshots, etc. Emphasis is also on spatial relations, unlike the drawings or artwork in which spatial relations support some other messages. So it is an analog of what is represented, unlike word, tables and digital data. Now, just to summarize, maps can help to visualize the spatial relationships between different features. If I can give you the example of city environment, the roads, the drains, the buildings, etc. This can be helpful for navigating unfamiliar areas or for planning a route, etc. Maps also show relationships of various geographic phenomena, like the relationship between population, density, the economic classes, and also the landscape. You just imagine about it and you would find spatial answer while posing the questions. Maps can be used for scientific purposes also, as map used by scientists to study Earth's surface and its natural resources. In modern day, we talk a lot about climate change. So there also the minute spatial informations are required and they are being used by the scientists. They can also be used by scientists to study environmental issues, which may be happening because of activities which are occurring far away from the place which is the hotspot. But one need to take care of map symbols and signs representing various features on the Earth's surface. I mean to say here the legend. Then maps are selective since they show only selected information which appear on the maps. And also the orientation. Maps can be oriented in different ways. This can be confusing for people who are not used to reading maps in a particular orientation. So all of them, they formulate the spatial information.